Okay, so just to be clear, I don't have like an agenda. I didn't come up with a syllabus for this or anything because I've been running around getting stuff on the hub and stuff all day. But I'll just I'm probably going to do this all in the terminal, so I'm going to go ahead and share my screen, everyone on Zoom. Um, okay, everyone see my terminal. Um, hide some of this stuff. Cool. Okay. Okay. So yeah, like I said, I don't really have an agenda. I just thought we would kind of talk through some of the details of object-oriented programming and specifically, and I'm happy to talk about any other style of programming too, pretty much. So just for some context here, um, I learned C in 1995 and have been programming ever since. C and C++ were my first languages, and C++ is a very object-oriented language. So I've been doing object-oriented programming for 31 years or something. Um, there's lots of other styles of programming languages, and I've worked with pretty much every style of programming language at some point in time. And if we have time, I'll be happy to talk about functional programming or something like that, if or whatever else people are interested in. Okay, but let's start with object-oriented programming. And I'm going to just be coding in like an empty file. Like this isn't, I guess, if you guys want, I can put some of these files on the Slack later once this is over. But I'm just going to make a directory called demo. I'm just going to work in here. Okay.
Hey Noah, could you make your font a little bigger? Sorry.
Yeah, no problem. In fact, it's hard to see on the screen here. So, okay, how's that? Is that better?
Yep.
Okay. Um, Something else I started doing in the 90s was Emacs. If you're not an Emacs user, that's fine. I'm going to use Emacs. It's just a text editor. Using Nano is fine, using VS Code, whatever you want to use. For right now, I'm just going to be kind of talking through some stuff. Okay, I'm just going to open up a file called example.py, and I'm mostly just going to kind of work here and, like I said, mostly just talk through things. Okay, so big picture behind object-oriented programming is that before object-oriented programming, there was just imperative programming, or not just, but that was kind of the main mode of programming. Imperative programming is like you have a list of instructions that the computer goes through one after the other, and that's pretty much what imperative programming is. If you get down to like really low level, like if you're working in C in imperative programming, then what you're doing is you're telling the computer to like move a number from memory to a register and then do some math on the register and then move it back into memory, that kind of stuff. Like, but it's all about managing a finite set of states and doing it with like commands that get executed one after the other, kind of sequentially. Fundamentally, all programming that we do, just about all programming we do, is imperative programming. Object-oriented programming and functional programming are imperative in the sense that the computer is going to go through a series of steps that you give it. But what's different is that object-oriented programming and functional programming and other ways of programming have strategies for organizing those steps and organizing functions and data together. So, um, okay, I've been debating whether or not I'm going to use this as an example. But basically, when back in the 90s when I started programming because I wanted to program computer games. Honestly, that was why many people my age at the time in the 90s started programming. And I honestly think computer games are a really good example for object-oriented programming. So I think I'm gonna use some very simple kind of adventure game examples here. Okay, so using adventure games as an example, invariably in an adventure game or in like whatever you're programming for neuroscience, um, you're going to have some data, and there's going to be different types of data. Okay. And fundamentally, this already exists in Python. So let me just, sorry, I'm just going to get a Python instance over here. Okay, so here I'm running Python over here, and this is my text over here. So there's a function in Python called type. And so if I say what's the type of 10, it tells me it's an integer, right? And if I say what's the type of ABC, it tells me it's a string. Okay, what about the type of type? It's type. Um, what about the type of an object? That's type. How many of you know what object means in Python? Okay, okay. All right, so it's called object-oriented programming for a reason. And the whole kind of one of the core philosophical things in object-oriented programming is that everything in the programming language is an object. Okay, so types are objects, strings are objects, integers are objects. These are all object. Object is just a name for like something that exists in memory. But it's not just something in memory because like a number is something in memory or a string is something in memory. Objects also have what are called methods attached to them. So kind of the fundamental idea here is that data often has kind of native operations that goes with it. So with a string, you can maybe append to the string or add two strings together or something like that. Those are kind of fundamental string operations. And when you're programming code that's going to handle data, it's often very convenient to write to kind of explain what the data is and then explain what the operations that can happen on the data are altogether. So, okay, so now I'm going to back up and use this adventure game example. So let's suppose we're writing an adventure game. This is a very simple adventure game. It's not going to do anything fancy like graphics, but we're going to need to represent things that the character, the player can carry. Okay, so for that, we might define what's called a class. And a class is just a way of saying, here's some data that has operations that go with it. We're defining that right here as a class. So I'm going to say class item. And then I put a colon. Okay, so what I'm doing here is I'm declaring a class, and class is sort of like an alias for type. So this is creating a new type, which is going to be an item type. And you can put a doc string at the top of your class. I'll skip that for now. But now in Python, and let me just pause here. I'm assuming people want to know about object-oriented programming in Python. Okay, because it is a little different in other languages, but Python is a perfectly good example language. So, so we're going to declare this class called item, and then when we're running Python over here, we're going to create a new item by saying something like new item equals, whoops, item, like this. So this is sort of like we might do for another type. Like you've probably seen this kind of construction before. Now many of the types built into Python, like string, you wouldn't normally call this way. Obviously, if I run this, it's going to not know what item is yet because I haven't defined it. But if, for example, you call string, it gives you back an empty string. So this is so string str is also a type, and you can create a string by calling the string type as if it were a function. Over here for item, we're going to define something called underscore underscore init underscore underscore. This is called a constructor, and it is basically the method of item that gets run when you create a new item. So when we call over here, when we call this item open parenthesis, close parenthesis, what Python will do is it'll say, oh, item is a type. There's this definition of the type under this class label, and there's this underscore underscore init function defined as part of the type. So that's the constructor. So we're constructing a new object, so it'll run the init function. Okay, let's think about what this looks like practically though. So the init function always takes at least one argument, which is called self. And self is the new object that has just been created. So over here, when we run new item equals item, open parenthesis, close parenthesis, Python behind the scenes goes and allocates some memory for our item. And it then calls this init function and passes that memory that's been allocated as self. So basically, when this function gets called, we're initializing an item, and this is the item we're initializing. Oh, and I'm just going to say our item needs to have a name. We need to know what the name is of the item is. And let's say it has a weight. Okay. So we've now made it, what I've said here now is this is a constructor, this is our initialization function, this is the object being constructed, and the constructor has two arguments that have to be passed. One is its name and one is the item's weight. All right. And then inside of this function, I can do whatever to initialize the object. So for example, I might say, okay, self.name is name. I just want to make a copy of that name argument. And I'm going to attach it to this self object. And this is sometimes called a member variable. It's like a member of the class, the name. So if this function gets run, for every item that's created, every item will have a name, right? And then I might say something like, okay, if weight is less than or equal to 0, I'm not, sorry, I'm not programming in C. If weight is less than or equal to 0, I'm going to raise a value error saying weight must be positive or greater than 0. Okay, so this is a way to check to make sure that if you have an item, if someone's created an item for you, they can't have given it a negative weight because that will break things. Negative weight items will break our, I don't know, our attempt to calculate how much you're carrying or something like that. So we have this this logic here that basically says if you try to create an item with a weight less than 0, we're going to raise an error. And then we'll say self.weight equals weight. Okay. That's just an initialization function. Pretty much every type or class you create will have some initialization function because you need to initialize the data in the object when you create it. Does this make sense so far? Or does anyone have any questions so far? Okay, we're right. So let's go ahead and define something else. Now, in a lot of object-oriented programming languages, you're really encouraged to use what's called encapsulation. So there's kind of these three principles of object-oriented programming that Python doesn't really lean into super hard. But the three principles of object-oriented programming are typically inheritance, encapsulation, and polymorphism. Inheritance means that we're creating an item right now. If after we create this item, we want to create another kind of item, like a special kind of item, like a backpack, that's an item that can both is an item that you can carry, but also can have things inside of it. We're going to take item and we're going to add some additional functionality to create backpack. And so we're going to inherit from item. That's what inheritance is. Encapsulation means that you can take some of the data and you can keep it private from the rest of the world. So for example, we might have some sensitive data inside of our item where if someone else edits it, it's going to screw up everything in our program. So we don't want other people to edit it. We only want to edit it in certain ways. And so we would essentially keep that data private inside of the class, and then we would write some methods that let people edit the data, but that way they can only edit the data in ways that are kind of approved by us. Does that make sense? Okay. The last one, polymorphism, is what's the best way to describe this? Everything in Python is polymorphic, so it's a little weird, but the idea is, so for example, okay, actually, we'll just write an example of polymorphism. I think explaining this is going to be less useful than if I just showed. So let's actually use some of these principles though. So first of all, self.name, anyone can edit this. Once you've created the object, you can always edit .name, and that is true of all Python objects. You can't really have private data in Python. Python doesn't let you do that. But there's a convention, which is if something starts with an underscore, you're not supposed to ever edit it. It's supposed to be private. So this is basically how we do encapsulation in Python. We say underscore name and underscore weight are our variable names, and that tells everyone who's using this code that they're not supposed to ever edit those directly. Okay, so now there is no at this point, if we create an item, we'll have the item dot underscore weight, but we won't have an item dot weight. So let's write a method that lets us access the weight. So the idea is would be called like this. So if you've got some item and you call wait parenthesis, close parenthesis, it'll run this method and it'll automatically pass my item as the self object here. So when this code gets run, it runs this function and it'll pass the object you're running it with as the self object. And we can just say return self._wait in this case. Okay. Now in Python, this paradigm is not that common in Python because there are no actual private data in Python, so people often just ignore this kind of thing. But if you look at languages like Java or C++, or a lot of other object-oriented languages, you'll see that you almost never access data by just requesting the data from an object. You have to run a function that returns the data instead. That's just a very common kind of thing. And you'll see why in just a second. Okay, so right now, this is going to be our whole item class. All the item does is track how much it weighs. Okay. All right, let's write another class now. We're going to write a class called backpack. A backpack is an item. So we're going to inherit from item. And by putting it, item in parentheses here, that tells Python that we're inheriting from the item type when we make the backpack. If we don't write an init function for backpack, it will just use this init function, and that's polymorphism. Even though we haven't written that function, it knows to look it up in the inherited or in the class that we inherited from and run that function instead. But maybe we would want to. I mean, maybe we want to have an init function. So let's suppose we do. We'll say def __init__. This backpack, we may not need a name because it's going to be called backpack. So I'm not going to have a name argument. We may still need a weight. And we may need something like weight capacity. How much can this backpack hold? Okay. We want the item part of this. So this backpack is both a backpack and an item, right? So we want to initialize the item part of the backpack. So what we can do is we can say super __init, and then what we're calling here with the super just means super type or super class. We're calling this init function. So this line right here references this initialization function. And so we need to give it a name and a weight. So the name is going to be backpack, right? And the weight is going to be the weight that we were given. So this line will run this function on our backpack, our newly created backpack object. Okay, have I lost anyone here? Is this all still making sense?
What's the super?
Yeah, so the super, so this super function only really works inside of methods of classes. So it has to be a function inside of a class. And the super open parenthesis, close parenthesis, essentially stands for this type. So we're saying, hey, hey backpack, we know you're inherited from item. So run the items initialization function right off the bat. Yeah. Okay. Cool. We also have this weight capacity, so I'm going to say self._capacity equals weight capacity. We probably should check if it's -2, but I'll just leave it for now. Okay, so we've written a new initialization function. Now let's write a weight function. Now, and actually I meant to put one more thing up here. We're going to say self._contents equals an empty list. Okay, so this is a backpack. It can have things inside of it, right? It can have other items inside of it. Okay, so now we want to return the weight of the backpack in this method. And we could, if we don't write this weight function, if I just delete this line and we leave it with just the initialization function, then the weight function will run the items weight function and it'll just return its weight value. But the weight of the backpack is the weight of the backpack plus everything inside of it. So we want to write a different weight function for backpack than we use for item. Does that make sense? Okay, so we'll say um, backpack weight equals super dot weight. So that calls items weight function. And then we'll say for IT in self dot underscore contents, BP weight plus equals IT dot weight. And then we return that backpack weight. So now the trick here is we are assuming that everything in the contents list is itself an item. And as long as we make sure that nothing gets added to the contents that isn't an item, then all of the items will have weight functions. And even if we put a backpack inside of a backpack, this will still work because it will call, because when we get to the backpack inside of the backpack, this it will be a backpack. And when we call its weight function, it's going to call this weight function and it's going to add up all of its contents. So this is kind of, okay. Did people follow that? Okay. Yeah, okay, so basically we're just iterating over this list of items that are the backpack's contents, and we haven't written the function to let you add something to the backpack yet, but we will in a second. Basically, it is going to be one of the items in the backpack. And we're going to enforce that everything that goes into the backpack has to be an item. And so every item has a weight function, right? So we can absolutely call the it.weight function. And if it's a normal item that just has a weight, it'll call this function. But if we put a backpack inside of our backpack, then that backpack will call this function. Okay, yes, it's a little convoluted, but I hope that made sense. Yeah.
And everything will be seen by the class, or sorry, I don't know if it's right, every instance, if you were to make other objects, will see these, is there like will, or no, sorry, I think that's the wrong word. Everything here can be passed down to any other thing that we create.
Yes, you can, yeah, all of these classes, you can always inherit from any class pretty much. Yeah. So there's, if you have some type, you can inherit from that type. And that's pretty much always a lot. So if next we want to make like, I don't know what you inherit from a backpack, but like some special backpack that has special properties, we could inherit from backpack and make a special backpack type. And it will inherit whatever we have in backpack, and which in turn inherits from items. So all of the item functions will also get inherited.
And it only goes one way.
It only goes down. Yeah. Yeah. Okay, let's define a function that like add item. So we have self, and then I'm going to call the item it again. And basically we want to just make sure, because if this isn't an item and we add it to that list, then this is going to cause an error when we ask for the weight, right? So we want to make sure this is an item. So I'm going to say if not is instance it item. And I'm realizing not an item. Okay, I'm realizing that I'm doing something I probably shouldn't have done. In Python, it is traditional to capitalize the names of types. Now, I know Python itself doesn't do this. str and int and all these are not capitalized. But when you're writing types, you're supposed to capitalize them. So now this is not required. This is just a convention. But I probably should have called this item like this. And then I think this would be backpack. This would be item. I think this needs to be item, and I think otherwise I'm fine. Okay, so there I fixed that. So we've got capitalized types, lowercase variables. Okay, so once we've checked that this is an item, we're just going to say self dot underscore contents dot append it, and that's all we need to do. that will add the item into the backpack. Okay, I'm gonna save this file. And I'm gonna jump over to my Python instance, and I'm gonna say from.example import item backpack. So since my file is called example.py and it's in this directory, you can say from dot example and it will go look for an example.py in your current directory and it will import these item backpack from them. Oh no, okay. Apparently you can only do this if you're inside of a package already. I actually think I might be able to do this with just from example. Yeah, okay. Sorry. This dot is for when you're inside of a package, like you're writing a Python package. Since I just have example.py in this directory, I can just import an example. Does that make sense? No? Okay. So when in Python, when you say something like whoops, 1 second. Okay, when you say something like from numpy import as array, you're saying go find this package on the file system and import whatever. If you're editing a file inside of the NumPy library and you want to import as array from inside of NumPy, that's when you use this dot syntax. Sorry, I shouldn't be pointing. I should use my pointer here. So yeah, that's when you use this dot syntax. Since there's a file called example.py in my current directory, it sees example as referencing that file. It finds that in the directory. And so when I import item in backpack, it goes into this file and imports those. Okay, sorry. Does that make sense now? Long story short, I've imported item in backpack into this Python runtime. So I can go ahead and say, I'm going to make an item. I'm just going to make it a generic item. I don't know, rock. It's a rock and it weighs 10, whatever our unit is. I haven't talked about units, but that's kind of different scope. Okay, so now we've got an item. If I just write out item 1, it's saying this is an item type from example.item. And I can say, hey, item 1, what's your weight? And it's 10. Right? So hopefully this makes sense with what we wrote over here. Now I'm going to make another item. I'm going to say BP equals backpack. And this backpack is going to weigh 1 and it's going to have a capacity of 50. Does that make sense?
I was wondering the entire time if you can make a capacity, but the answer.
Yeah.
I thought you had to do it in the other file, but you make the capacity in there, right?
Yes. So the reason it works, it's here, is because if I go up here, the weight capacity is an argument to this init function. Yeah. Yep. So BP.weight is 1 because there's nothing in it. It's just the weight of the backpack. But now let's say we say BP.add item and we put our item 1 in there, the rock. Okay. Now what's the backpack's weight? Well, it's 11 because it's the weight of the backpack plus the weight of the rock. And the backpack's weight function knows to go to add up the contents as well as the object. Okay. Now, if on the other hand, we say something like item 1, add item, we try to put the backpack in the rock, it says there's no add item for an item function. There's no add item method for an item object. And that's because we only define that for backpack. Okay, what questions does everyone have? Yeah.
So,
Sorry, behind you first. Yeah.
don't need to have. Well, I guess the first function can call objects from the second function.
So when you say function, are you sorry, 1 second.
Function with
So like this function, for example. So and this isn't real consistent in Python, but functions of classes are usually called methods. Like a method is the name of a function that's attached to a class. So okay, so you're saying so ask your question again.
and will later be
You can define anything that you Yes, yes. So, right. So, this wait function can call any other method in the item type. Yeah. So the way this actually works is, Python, Python has a weird way of lazily compiling things. So when it loads this function or this file, it will create these types. When it runs the init function, it will have come up with all of the man. Yeah, this is maybe getting a little in the weeds. Long story short, uh, yes, any method inside of any class can call other methods of the same class or any inherited method. I think that's the answer to your question. Okay, other questions? You had a question?
Yeah, I think so.
Yeah.
This is also, it's not a very hard question, but, the way these two are talking to each other is that you're in the same directory that the script is in, so instead of like. Interacting with like a package or like something, you can also like get things from your script and return it, like interact with, sorry.
So I think the answer to your question is basically Python sees the script I wrote as a package when I use it this way.
Oh,
So just let me be a little clearer about that. Here in this directory, I've got this example.py file. So because there is a file in this directory called example.py, I can just say from example
okay, that was my
import
question.
item. Yeah,
Okay, so it's seeing this as a package.
essentially, yeah. Yeah, when you have something, when you have a file like this in your directory, it works that way. Yeah. Okay. Other questions? Yeah.
Stupid like understanding question. If I want to make another backpack with a higher capacity, I would just name it BP2
Yeah.
equals, and then I can just, okay.
Yeah, and actually, I maybe should have been clear about that, but yeah, so this lets you separate out multiple different, like you can have many items of the same type that are all different, and they can all have different weights and capacities. So BP2 maybe it's a backpack that weighs 10 pounds and holds 100 pounds or something like that. And that's fine. And now we can, if we want, we can put our first backpack in our second backpack, and now BP2.weight ought to account for all of that. Yeah. So you kind of see, so hopefully you can see a little bit of like, there's an intuitiveness to this arrangement of data and methods. Like very often you've got data and the data can get transformed in various ways. But if someone comes in and like changes one of the numbers in your object, suddenly everything's broken, right? So if trying to come up with a good example of this. So you could imagine, yeah, you could imagine that instead of having a weight function here, we could have kept this weight function, but in the add item, we could have changed the weight variable instead. Did I lose everyone there? So this is one way we could have written backpack, and this is probably the smarter way. A less good way would be if, okay, let me. Okay, so we're going to rewrite this just slightly. I'm gonna comment out this weight function and say we're just going to inherit the weight function from item. Okay. But when we add an item, we append it, and then we say, oh, our weight needs to increase because we've now added an item to it. So we're going to add it.weight. Right? This will work too, and because we've gotten rid of this definition, so it will inherit items definition, and all item does is return the underscore weight variable, right? So this is another way to achieve exactly the same thing. The problem now is if someone looks at the code and says, oh, I can just append something to the contents, but they don't change the weight. Now it's broken. Now the weight is incorrect for what's in the backpack. This is why we have private data. This is why we like to have private data, because as long as weight and contents and capacity are private and nobody mucks with them in ways we don't expect, then we can make sure that our code always works. But if someone comes and edits the data behind the scenes or whatever, then they can break the paradigm and they can make our code break. I don't know if that was super clear, but did that more or less make sense? Okay, yeah,
But it's not like really locked, it's just the other person has to know that they're not supposed to.
exactly. Yeah, so in other languages, like in Java and Scala and C++, then it really is locked. Now, I say it's really locked, but like someone who really knows what they're doing can probably get around it, but it's not, the intention is not that it's like, this is not about security. This is about code correctness. So privacy is not about like whether or not other people can read it so much as whether a programmer can accidentally do something that breaks the code. Yeah.
What about when you're like analyzing your data and you're importing functions that have the, like, that's also, like, we could actually edit those,
Uh,
like with the underscore, like it's the same thing where it's just a courtesy.
yeah, so like for example, if like in scikit-learn, you can when you create a linear regression object, there are some underscore variables that you can change. You shouldn't change those. If you do, you might break the code and it might not work correctly. It might still run, just give you the wrong answer or something like that. That's kind of the danger. Um, uh, since we mentioned scikit-learn, I'll just add that there's another paradigm that scikit-learn uses, where they say like if you have linreg dot I forget what linear registration produces in terms of variable names, but they'll have like a variable underscore. They'll have variables that look like this, where the underscore is at the end. They use that, and some other packages use that to indicate that this is something that has been set for you to read. Like you're supposed to look at this value. And the way scikit-learn uses it is if you provide a parameter, like you say, okay, like random forest, for example, in the random forest in scikit-learn, you can say, I want this many trees in the random forest. If you provide n trees, then it'll be forest.n underscore trees. But the actual predictors are called forest.predictors underscore, and those are the individual trees. And that's because the trees were created as part of the algorithm, they weren't a parameter to the algorithm. This is something that like machine learning, a few machine learning libraries use. It's just a kind of similar paradigm that sometimes gets confused with the privacy paradigm, but it's different. Underscores at the end are not usually part of privacy. Okay, what other questions do people have? Okay, so this is a pretty simple example. Like inheritance can get very complicated, where you have like many layers of inheritance, and in fact, you can have so uh, typically the example I would use here is something like we would have an item, and then we would also have a type called container. So like a container might be something that you can't pick up that's like too heavy to pick up, like or that's attached to the floor. It's not an item, but you can put stuff in it. Items are things you can pick up. They have a weight. They're not too heavy to pick up. A backpack is both an item and a container. And so in that paradigm, you want to inherit from both. You want to inherit everything from item and from container into backpack. And you can actually do that in Python too. I won't. I'm not gonna flesh out this whole example. I just want to let you know that it's possible. But you can say like item container, and then you have something that inherits from both. And then some of this gets tricky because super doesn't refer to a single class anymore. But you can specifically say, oh, I want to call item dot underscore underscore init or something like that. Honestly, multiple inheritance isn't. It's one of those things that the object-oriented community created back in the 90s and then kind of decided was too hard. If you look at like more contemporary languages like Java, for example, doesn't actually allow multiple inheritance in the way Python does. And even C++, you can do it in C++, but it's considered kind of an anti-pattern. Like you shouldn't do it because it creates too much complexity. But it is possible. And Python actually does use it fairly often, weirdly enough. Okay. It's about 3:40. I mean, I can talk a lot more about this. I don't know how, if what I'd say is if people are thinking about using this in some way, let's talk about that as opposed to me just kind of blabbing on about it. Or if you have other questions, specific questions or other questions about other kind of programming. Yeah.
I guess, when would you, Like the only time I've used this is like in intro to comp sci when you're
Yeah.
like games, like a ladybug that has this many dots, like something like
Yeah,
that.
yeah.
When do people use this in like analysis? Or do you not? This is just like.
No, so my library in NeuroPython has a bunch of has a bunch of classes in it. But so for example, in NeuroPython, there is a class for a surface mesh. And that class has functions attached to it that let you do things like find the neighborhood of a vertex, like all the other vertices right around it, or calculate the normal vectors for every triangle face. So like it's these kinds of methods that are just very inherent to meshes. And then there's another type called cortex, which represents both the gray matter mesh and the white matter surface mesh, and lets you do things like look up where a voxel is inside of the cortex, or these kinds of like native cortex operations. And then there's another class called subject. And so far, none of these are inheriting from each other. These are just like containing each other, if that makes sense. Like there's a left hemisphere and a right hemisphere object in the subject that are both cortices, and the cortices have a white surface and a gray surface, and they're members of the cortices. So it is a very legitimately useful way to organize code. I often find that a very simple class like this is a really nice way to organize a little bit of code. People in general are pretty familiar with them in Python. They're kind of everywhere in the ecosystem, so it's even if you're not familiar with like how to write a class, you've almost certainly used a bunch of classes and have seen them used. So I don't know. I'd say I find simple object-oriented programming very useful. I find that as soon as you start doing complicated things like multiple inheritance or having like a really complicated inheritance tree, that can get less useful because it suddenly becomes harder to maintain and just is just in general more complex. Yeah, I'm not sure what I mean, historically, object-oriented programming kind of came into vogue around the era of Java, which was like 90s. And I would say it kind of went out of vogue by 2007 or 8. And it's not that it disappeared, it's just that people realized that it's useful as a component of organizing programs, but it's not always best to organize an entire program as everything object-oriented. And there's lots of reasons for this. It turns out that like these examples with like items and backpacks are very simple and they work really well, but pretty quickly you get to cases where it's like, well, there's two objects and the code to deal with them really needs to be in both. And then it gets really complicated trying to figure out where your code lives and how it accesses the private data. In a tightly controlled language, you can't necessarily access the data of like backpack can't see the private data of item in a like Java. Yeah, anyway, without going too far in the weeds. Yeah, other questions or thoughts or anything? Yeah.
I was just thinking back to all of the way codes are organized from pandas, for example, they have data point dot something command and then brackets. Is that also part of the object oriented?
So okay, actually this is a good question, and I'll maybe let's talk about that a little bit. So okay, I'm gonna undo this thing we did here and undo this way. So we've got the old way of doing it. Okay, so let's suppose we want to ask something like we want to be able to get the length of like the number of items in this backpack, and we want to be able to get out like this first and second and third items of the backpack, right? So if we want to, what in my mind what that means is I want to be able to run something like len of backpack and have it tell me that there's one item in the backpack. Right now, it's going to say backpack doesn't know how to calculate a length. You haven't told it. Over here, if we want to support length, we can write a function that's called underscore underscore len underscore underscore. Okay, these double underscores are a Python thing. They're called dunder functions usually for double underscores. And basically the underscore underscore before and after whatever it's called is a symbol. It's just a signal to you that Python it thinks something special about this function name. And in this case, underscore underscore len underscore underscore is the function that Python calls when you run len on an object. So if we define this, so I'm going to say self here, just as a dummy here, I'm just going to say return 0. Okay, this is a really dumb length function, but it'll work. Now, so over here, I've already imported backpack, so I will need to quit Python to have it recompile backpack basically. So I'm going to exit, and then I'm going to start Python back up. And then say from example import item backpack. Okay. So if I make a backpack and then ask for the length, it's 0 because it calls this function. So these double underscore functions are ways that you can interact with kind of the native Python space. And the specific example you asked about, get item. So let's first of all fix this length. This should return the length of self dot underscore contents. And then the underscore get item function. This is what is called when we say something like BP of 10 or BP of 1, like this with the square brackets. So if I want to get the first item out of the backpack, I would usually use BP of 0. And over here, we get an index. So the get item function takes the object itself and then the index that gets passed. And here we're just going to return self.underscore contents index like that. Now, again, I'm going to have to quit to. So I'm going to, okay, so I'm making this rock again. I'm making the backpack. I'm going to add our rock to the backpack. And then if I say length of backpack, it's going to tell me it's got 1 item in it. And if I ask for the 0th item, it's going to give me back that item. Now we didn't write a way to get the name out, but hopefully that's a rock. Yeah. Does that make that answer your question? So there's a whole bunch of these are not the only ones. There's init, there's underscore len, there's underscore get item, set item if you want to support something like BP of 0 equals item. There's a whole bunch of these. Pretty much like if you want to support addition, you can overload the underscore add underscore function. If you want to support multiplication, so you have like BP times something, you can overload underscore mul, MUL underscore. There's a whole bunch of these, and they're pretty much for every kind of operation you can do on an object that's native to Python, you can overload it some. Okay, other questions?
I see a lot of, I think, classical object-oriented programming in SciPy.
Okay. I've never used CircuitPy, so I'm not going to be able to tell you very much about it, but that doesn't surprise me. Like pretty much any Python library is going to have at least a little bit of object-oriented code in it, almost always.
It's like after defining all the classes and types and items, what do we do next? Now we have everything.
Yeah. So, I mean, this is a good question. I mean, object-oriented programming is fundamentally a code organization technique. It's a way for you to organize your code so that it's kind of easier to understand and to find things. And so there's not like the question of what do you do next is the same for any Python code. Like I can't tell you what your Python code needs to do. But I can tell you how to organize it so it's easier to remember. I guess I'll say is that a lot of times what I do is I will be like, okay, I'm writing something for a script. I'm just going to get it to work. I'm going to write out all the code. And it's only later after I've run the script a few times and had to modify it a few times that I'm like, oh, you know what? There's like there's a concept here that has a few operations on it. And it'd be really nice if I didn't have to rewrite all that code every time I use that concept. So NeuroPython, for example, completely grew out of this. It was like every time I wanted to load in a free surface, I had to like load it in and then parse the nebabble data and then turn it into a mesh and do all this stuff. And I just wanted to have that happen. I just wanted a type that would do that for me. And so I eventually wrote the type after I realized kind of what the pattern I was using was. So that's sort of my advice about writing these is like, once you've done some kind of operation enough times in Python, you'll eventually realize, oh, this is an operation I'm repeating. Let me write it into a class so I don't have to do that anymore. But you can also write it into a function. I mean, there's like honestly, the whole idea of the functional paradigm of programming is like, don't use objects. All your data should just be public, but you shouldn't really ever change it. Like if you've got data, you shouldn't change it. You can just pass it to a function and have the function return you new data or updated data or something like that. It's a different way of organizing this kind of stuff. And you don't have to use one or the other. You can use both of them together. They're just kind of strategies. Cool. Other questions? Okay, I'm always happy to talk more about programming languages. So if people have questions, you can always find me later.